Let's work with number A. Let's start with number A. Number A says x squared to the power of 3, which is very similar to the example that I did here. So what are we going to do to these exponents that are raised here? X is raised to 2 exponents, basically. So what do we do to those exponents? Please say something, participate, guys, so that I know you're here and you're listening. Let me do this, make it a little bit bigger for us. I think that's a bit better. We multiply. Thank you very much. We multiply. Thanks, Bongumus and Butlali. So we're going to take the 2 and the 3 and multiply them. All right. So then it's going to be x to the power of 2 times 3. And so ultimately my answer is x to the power of 6. Thank you. Wonderful. Okay. Let's move on to number B. Number B is x squared to the power of 5. Okay, so as we know, we are multiplying my exponents. So this whole expression will then be x to the power of 2 times 5. And then my answer will be x to the power of what? 10. I know this seems very easy, but learners tend to confuse adding exponents with the multiplying of exponents. Okay, but obviously we're going to do combinations a bit later on. Okay, and this time we have a 2, which is outside the bracket. Do you think I have to distribute the power to this one in front? Do you think the rule works like that? Do I have to? Thank you very much, Mene. No, it doesn't. No, it doesn't. So that 2 will only be distributed to the bracket. So it will then be 2 times x to the power of 3 times 2, which is 2 times x to the power of what? 6. Okay, so these are 3 questions for rule number 1. Now we're going to expand. I zoomed out a little bit for anyone who wants to take a screenshot right now. We can expand this law to another law of exponents, which is law number 4. Okay, and that is actually what we are doing today. That is the distributive law. I'm hoping by now everyone has taken their screenshots. So the distribution law, distributive, says if you have multiple bases, do you guys agree that so far we've only dealt with a single base raised to 2 powers? So now we're just expanding it and we're saying this is the same law, but this time we have multiple bases. So if you look here, what are my different bases inside the bracket? What are my different bases inside the bracket? We're over here, red arrow. My 2 different bases are x and y. Thank you. Okay. So if you have such a case, then you take your exponent that is on the outside of your bracket and you distribute it. So you will multiply it with the exponents of the first base and with the exponents of the second base. So if you can look here on the side, that is exactly what we are doing. We took the first one, the first exponent, and multiplied by my power that is outside. And then I also took my second exponent and multiplied with the power that's outside. Okay, so that's what we are doing now. So if you look here, we went up to ABC. So this is number D. And we have x squared times y, all raised to the power of 3. So then that means we're going to have x. I'm just going to draw arrows to remind us that we are distributing. Okay, that means we're going to have x squared times 3. And y, if there's no exponents there, then what do we have, guys? If there is no exponents, then we can see it's a 1. Thank you. It's a 1 times 3. So then my final answer will be x to the power of 6 times y to the power of 3. Nice, guys. And the reason it works like this is because of law number 1. Remember, what does a cube say? If I say 2 cubed, This is the same as 2 times 2 times 2. 2, not 3. 2. Right? So if you take this whole bracket and you say x squared y times x squared y times x squared y. Rule number 1 says if you are multiplying with the same base, what do you do to the exponents? Let's see if we remember the first law. Law 1 of exponents, thank you, Buhlali, we add them. So if you take all of the x's, x, it will be to the power of 2 plus 2 plus 2. And y will be to the power of 1 plus 1 plus 1. And this will give us the same answer of x to the power of 6 times y to the power of 3. Do we see where this law comes from? So instead of going through multiplying all of those brackets, you can just take the power that is outside and distribute it between everyone inside. Okay. Now, there's one thing that I forgot to mention. This law does not happen if you are adding powers. So for instance, let me write here, not, that is way too thick. I'm not sure why. Let's see, let's do this. Not 4 plus or minus. What I mean about that is if you have x squared plus y cubed or raised to the power of 7, you are not allowed to distribute the 7. Okay, so in this case, we cannot distribute. Now I'm saying this because I know we're going to confuse these laws. So just write these notes down so that you have them already in case you wonder about them. So you cannot distribute if there's a plus or minus. You can only distribute if there is a multiplication or division. And speaking of which, okay, for number E, we have a division. Okay, so we're still going to distribute it. So it's going to be in the numerator, it will be a to the power of 1 times 4 divided by b to the power of 1 times 4. And then your final answer will then be a to the power of 4 over b to the power of 4. Okay, so far what we have done, can I get a thumbs up, thumbs down from the class? Are we following what I am doing so far? Okay, I see 1 thumbs up. Out of 19. Okay, 3, 4, 5. Nice. Thanks, guys. Thank you, thank you. Okay. Beautiful. That is D and E. I hope everyone who's taking a screenshot has done so. Let me zoom out so you guys can get a full screenshot of what we have done. There. So law number 3 is actually just assistance to law number 4. Okay, law number 3 says if you have 2 powers, you multiply them. And then number 4 is if you have multiple bases, you multiply them with every single power. Okay. Now let's look at number F. In this case, will the 2 also get the power of 3? Will the 2 also be multiplied or raised to the power of 3? Yes, because it is inside the bracket. Okay, so we're going to say 2 times 1, 2 to the power of, to the power of 1 times 3. And x to the power of what times what? X, thank you, 2 times 3. And y to the power of 2 times 3 as well. And tell me for z, it's to the power of what times what? Z to the power of 1 times 3. Thank you very much, Mina and Ashley. Okay, this will be equals. So then, now we have 2 to the power of 3, x to the power of 6, y to the power of 6, and z to the power of 3. Are we done with our question? Do you guys think we are done answering this question? If my question was simplify this fully, would you be done? No. What's left to do, Butlale? And everyone else? Is there anyone who knows what we still have to do with this question? Have we simplified fully? No, we haven't. 2 cubed. Remember, 3 exponent is cubed. I should probably say that. Let me do a note here on the side for us. If I have a squared and if I have a to the power of 3. So with this one, the 2 is a squared. And the 3 is a cubed. Okay. Wonderful. Now, let us simplify my 2 cubed. What's 2 cubed? How much is that? 2 cubed means 2 times 2 times 2. So my answer is 8. Nice. Thank you. 8 times x to the power of 6, y to the power of 6, z to the power of 3. All right. I'm hoping everyone is still with me. Hopefully we are. Hopefully this zoomed view is also better to see. All right, now we have a combination of a few laws over here, right? Where do you guys think we would start? Where do you guys think we would start? Where would you start with this one, guys? This will be number G. We're on number G now. I see top. I see 2 and 4. Buhlale, what do you mean by top? Do you mean distributing? I'm assuming that's what you mean. Distributing the 2 into the top. Oh, okay. So that's fine. You are allowed to do that. But I think for safety purposes, just to be safe, okay, we must stick to bed mass, which says we must start where? Bed mass says we must start with. Thank you. Okay, we must start inside the bracket. Inside the bracket, not necessarily division, but brackets. Because you first simplify what's inside the bracket before exponents. Do you see exponents come after brackets? So you say brackets, which means simplify what's inside. And then you can work with exponents. Okay, so let's see what we have inside my brackets. We have numbers, we have variables. There's a lot going on. Let's start with my numbers, okay? They're both positive, so my symbol won't do anything. Nothing's going to happen with my symbol. But we have a 2 and a 4. What is a common factor between 2 and 4? 2. Thank you. It goes into itself how many times? How many times? Thank you, Butlale. Once, and into 4. Twice. Okay, we're done with the numbers, okay? So it's 1 there and a 2 at the bottom. Now let's talk about the x's. We are dividing x squared by x. What happens when we divide? What do we do to the exponents? We subtract them. So then it will be x to the power of 2 minus what? 2 minus what? We have an x just chilling at the bottom. Minus 1, because if it's just x, that means it's x to the power of 1. And then as well, y to the power of 3 minus 1, all squared. All right. This seems easy, but there's one thing I want you guys to take note of, okay? When you are doing multi-step questions, try hard not to break them up. What I mean is, don't write here x to the power of 2 minus 1, and then you write equals x, and then you write here y squared, y cubed minus 1, and then at the end, somewhere they all come back together suddenly and they are one sum. Avoid doing that, okay? Try to write them as I am writing them. Whatever you are not working with, just rewrite it. You see that I still wrote my bracket with the 2. So let's simplify what's inside the bracket. That's 1 times x to the power of 2 minus 1 is just what? X to the power of 2 minus 1 is just X. No problem. Give me 2 seconds. I'm going to get there just now. And then y to the power of 3 minus 1 is y to the power of 2. And this is all over 2. And we have a squared at the top. Okay, Ilham, I see you asked about bed mass. So this is my order of operations, the order in which we do mathematics. Okay. Order of operations. All right, so order of operations says you start with brackets. That's what the B stands for. This is an acronym, actually, okay? B stands for brackets, which means whatever is inside brackets, simplify that first. So we went and simplified it first because we could divide 2 by 4, and we could do the first law of exponents inside the brackets. So you ignored everything else that is outside the brackets, you first work inside. And then the second order of operation is exponents. It's okay, Lucieva, welcome. And then the second one is exponents, okay? That means wherever you see an exponent, simplify it. So in this case, it's my square that is outside, which we now know that we have to distribute. Now, the rest of them, D and M stands for division and multiplication. And finally, A and S stand for addition and subtraction. All right, so let me give you an example where all of them are in a sum, okay? So if I have 3 plus 1 all squared times 3 plus 4. So the important thing to note here, LM, is you won't always have all of the bed mass operations in a sum. Okay, you just work with the ones you have. So first one is bracket, which means whatever's inside the brackets, which is in this case 3 plus 1, simplify that first. So leave everything else alone, do what's inside the bracket. So then you're going to say 3 plus 1, which is 4 squared times 3 plus 4. Okay, we're done with brackets. Now we move on to exponents, which means we must simplify this 4 squared. And 4 squared means, it means 4 times 4, which is 16. Be careful, it's not 4 times 2, it's 4 times 4. So then it'll be 16 times 3 plus 4. Now, after you've done exponents, you go on to division. There is no division, so you go to multiplication. So then we have to first do 16 times 3. And how much is that, guys? 16 times 3, let's see. 30, 6, 12, 18, 48. Thank you. Plus 4. And finally, we're left with just addition. And that means my final answer is 52. So you must always remember this. But, Ilham, you see that I put division and multiplication under one umbrella, and I did the same here with addition and subtraction. You have to follow this order, but if you have to choose between division and multiplication, it doesn't matter. The order in which you divide or multiply will not affect your answer. Same with addition and subtraction, they will not affect your answer, okay? So what I mean is if I have 4 plus 7 minus 2, if I first say 4 plus 7, which is 11, minus 2, that is 9. Or if I first say 7 minus 2, which means I'll have 4 plus 5, that will still give me 9. So with these two groups, division, multiplication, order doesn't matter. Addition, subtraction, order doesn't matter. Okay, I hope I answered your question, Ilham. And now let's finish off. Now we have a fraction and an exponent on the outside. What do we do with this exponent again? What do we have to do with the exponent? Magic word starting with D. Before we multiply, guys, you first Do what? No. Remember our law. What am I doing? What do these arrows mean? We distribute. We distribute. There we go. Okay, so this will be equal to x to the power of 1 times 2, y to the power of 2 times 2, divided by 2 to the power of 1 times 2, which will give us x squared, vocabulary, y to the power of 4 over 2 squared. Am I done with my question? Am I done with my question? No. What do I still have to do? What do you guys think I still have to do? I have to? I have not simplified fully. So what do I still have to do? Can we minus Ashley? We don't have any common bases here. Thank you, Butlale, 2 squared. So the x squared and the y to the power of 4 you can leave alone. But what is 2 squared? What's my answer for 2 squared? 4 over 4. Okay, how was G? Let's get a thumbs up, thumbs down on G. I have a feeling it was a little bit more challenging. But as long as you understand now what you were meant to do. Okay, thumbs up. Thank you. I see you guys. All right. Okay. Let's do a little bit more challenging ones. Again, we have a number that is outside the bracket, which means it's not affected by the exponents on the outside. So let's first look inside the brackets, okay? Because we always start with brackets. Can we simplify anything inside the bracket? Can we simplify anything inside my bracket? Mina says no. Everyone else, there's 20 of you in here. Butlale says yes with a question mark. I don't know what that means. Can we simplify anything inside my bracket, guys? Yes, guys. We have multiple bases that are the same. We have an x and an x. We have a y and a y. So we can simplify something inside the bracket, right? We're dividing. So what will we do to the exponents? We'll subtract. Let's start with x. It's going to be x to the power of what minus what? One minus one. Thank you. Y to the power of what minus what? 2 minus 1. Thank you. And then z is just on its own there, all to the power of 2. Now, this will give me 3 times x to the power of 0, y, z, or raised to the power of 2. We can still simplify something inside my bracket. And what is that? Let's look carefully. What else can we simplify inside the bracket? X. Yes, that is x. Okay, I got a question, ma'am. Where is the 1 coming from? Remember, if there's no exponent, my exponent is 1. Okay, so if I just have x, this is the same as x to the power of 1 because there's 1 of them. You see, so exponent tells you how many of them there are. And in this case, there's just 1 of them. It's all right. Welcome, welcome, Moratile. Okay. So what is x to the power of 0? I can simplify it to just a 1. Yes. Then it'll be 1 times y times z, which is just yz squared. Okay, now where do we go? We have done brackets. We are on exponents. So what is my magic word again? What do I do with this 2? What do I do with my 2? Distribute. Thank you. Redistribute. So y has to get it and z has to get it. So 3 times y to the power of 1 times 3. You see, there's the 1 again. Okay, there's the 1 again. Because y times 2, excuse me. Oof. Not times 3, times 2. Because there was no exponents, then we know it's to the power of 1 and z to the power of 1 times 2. Okay, so in a question, ma'am, how is it so that x can be powered by 0? Remember, LM, there was x to the power of 1 at the top and at the bottom. And since we were dividing, we subtract our exponents. So that means it will be 1, the one that is on top, minus the one that is at the bottom. Do you see how it works? Hopefully I've answered your question. Let me know if you're still unclear about anything. Let me move this down to make some space for us. Okay. Now, I will then be left with 3 times y squared z squared. Okay. Now we just times the 3 that is in front. Everything is positive, so my answer will be a positive 3 y squared z squared. Okay, thumbs up, thumbs down, including everyone who was asking me questions. Do you guys understand what we were doing now? There we go. Okay, thank you for my thumbs up. I see them in the reactions as well. Okay. And another one. You know I'm going to challenge you guys, right? So I'm going to put it up there. Then I'm going to move my brain break down so that we have some space. There we go. Okay, back to BODMAS. BEDMAS. It's BEDMAS now. I need to remember that it's called BEDMAS now. Do we have anything inside the bracket that we can simplify? Do we have anything inside the bracket that we can simplify? No, we don't. Right? Now we move on to exponents. For 2x to the power of 5, is there anything that we can do there? Anything that we can do for 2x to the power? No, there isn't. So I'm just going to rewrite it, okay? So it's going to be 2x to the power of 5 times. Now, how many different bases do we have inside my bracket? How many different bases do we have inside my brackets? 3. Thank you, Mine. We indeed have 3. Okay, we have a -3, not 3, -3. We have an x base, and we have a y base. So we will be distributing my 2 3 times. Okay, we'll be taking this, distributing it there, and over here. So I will say -3 all raised to the power of 3 times x cubed all raised to the power of 3 times y all raised to the power of 3. You do not have to do this step, but it will be helpful to keep track of what you are distributing where. Oh, 2. It is 2. It is 2. Thank you. To the power of 2. Okay, so I'm just going to split it up like this so that I can see everything that I'm working with and it's easier for me. All right, so I'm going to leave this 2x to the power of 5 here. Now, what is -3 squared? -3 squared. That's -3 times -3. Think carefully, guys. -3 times -3. When you multiply 2 negatives, your answer is positive. Nice, Ashley. Your answer is positive 9. You must be careful with that one. Okay, we always catch you out with that one. So then my answer here will be a 9 times x to the power of, what am I doing with my exponents? What am I going to do with my exponents? Multiply them. So it'll be 3 times 2 times y as well. You multiply them 1 times 2, okay? So now we have expanded, let me simplify them before I confuse everyone. Times 9 times x to the power of 6 times y squared. Now, we have expanded everything that we can, okay? But do you guys see that we have numbers that we can multiply out? We have a 9 and a 2. What is 2 times 9? What is 2 times 9? It is 18. Thank you, Ashley. 18x, and now we are multiplying. So what are we doing to my exponents? If I am multiplying, what happens with my exponents? We add them. So then it's going to be x to the power of 5 plus 6. And the y is just alone. So I'm just going to rewrite it as y squared. So then my final answer is 18 x to the power of 11 y squared. That was an eventful one. What do you guys think? That was a very nice one. Hopefully I did not lose anyone with this. Hopefully we're all still with me. This is your chance to take a screenshot while I see if anyone has a question. Yeah, this was a really nice one. I like it. Okay. Okay, it's time for our brain break. Is there anyone who wants to speak to me for our brain break, or are we all too shy still? Don't be shy, guys. Raise your hands. No one? Okay. There we go. Hello, Chantal.
Hi, ma'am.
Chantal, would you rather find a tooth or a nail in your food? Someone's tooth or someone's nail?
Ma'am, someone's nailed.
You were about to say tooth. You thought about it. Like, you know what? No, I can't do it. Teeth are too much for me. They're inside someone's mouth. Oh my goodness. But nail, guys, people who said nails, you know how dirty nails get, like underneath.
Oh,
Chantal is just laughing. Chantal, do you want to do the next one as well? Nobody else wants to talk to me.
yeah, ma'am, it's okay.
Okay, let's do the next one as well. Would you rather swim in a pool of Coke or a pool of milk?
Ma'am, a pool of Coke.
You're going to be sticky. As soon as you dry, you are sticky. But also, everyone who's saying milk, do you know how hot milk gets? Like, imagine milk in the pool in the sun the whole day, and then you come in and you swim in there. Ugh. What a difficult, guys. Thanks, Chantal, for speaking to me.
Thank you, ma'am.
Guys, milk. Like, I'll shower later. Guys, you're gonna stick. As soon as you start walking, you're gonna hear. It's terrible. Okay. Next one. Would you rather be transformed into Shrek or the Beast from Beauty and the Beast? I would choose Coke. I'm not gonna do the milk thing. You can't. Yo, but Coke is acidic, guys. Now I'm thinking of my eyes and burning. I don't know. This is actually a really difficult one. Everyone wants to be transformed into the Beast. Guys, the Beast is hairy and stuff. Wow. The Beast, wow, I'm just focused. Says the Beast for the money. I see you. I see you. The Beast did have a lot of money, didn't he? I didn't even think of that. Guys, Shrek was so happy in a swamp, man. He just didn't care. Nobody wants to be Shrek. That's hectic. Wow. I would probably choose Shrek. Just be chilled. Nobody bothers you. You're just there, man. And the last one, would you rather spend the night in a coffin underground or in a haunted abandoned hotel? So you're either in a coffin or in a haunted abandoned hotel. Fun is like, I'll take the hotel any day. And Min says coffin. The way they're alternating. Coffin, hotel, coffin, hotel. Okay, now hotel seems to be winning. Guys, you guys are not afraid of ghosts and stuff. Do you know what an abandoned building looks like? Like, it's scary. It's so scary. Buhlale, I can relate personally. Buhlale says, I love ghosts. I don't. I'm cool with ghosts. No, thank you. Elam will take both. Hectic. She was like, run. When you get to where you're running, the ghost is already waiting for you. Then what? I can't with ghosts, guys. I can't. That's where I draw the line. Okay, guys, let's stretch a bit. We can still have about 15 minutes of listen. And you know I'm going to make it worth it. Let's see my questions here. Check how beautiful my questions are, guys. Okay, let's get working with this one. I already know we're going to need a lot of space, so maybe I should move this one down. There we go. And zoom in a bit. There we go. All right. Elam is like, they're like comedy for me. I can't relate. Guys, I don't even watch horror movies just because of ghosts. Okay, I'm lying. I don't watch horror movies that involve ghosts. Let me say it like that. If it has supernatural stuff, no thank you. I'm done. Okay, this is number J. Whew, there's a lot going on here by number J, right? Now I'm going to write my nice bed mass rule over here nicely so that we make sure we follow it. Brackets. Is there anything inside brackets that can be simplified? Inside the brackets, is there anything that we can simplify? Ohlale says yes. What can we simplify? Ashley says no. There's only one set of brackets and they're here. I don't see anything inside my bracket that we can simplify. It's just 3 separate bases and there's nothing much we can do with them. Okay, so we're done. Exponents. Is there anything involving exponents that we can simplify? Yes. This guy over here, we can distribute, right? So since there's nothing in the brackets to do, we just distribute. So I'm then gonna have -2 all raised to the power of 3 times x raised to the power of 3 times y cubed again, all raised to the power of 3. All right, all over. We're doing nothing in the denominator. I'm just rewriting it as I have asked you guys to do in your assessments. Okay, what is -2 cubed? -8. This time it's a -8, okay? Because it's a negative times a negative times a negative. So 3 negatives give you a negative, okay? So this is -8. This is just x cubed and y to the power of what? Let's see if we can do my rule in our minds, in our brains. And y to the power of 9. Thanks, Buhlale. 9. Okay, and this falls all over 4xy to the power of 4 times 2x squared y to the power of 5. Nice, we are done with exponents, okay? Now, division and multiplication can be done in the same order. What do you guys suggest we do? If you are looking at your sum, what would you suggest we do? Because remember, these ones are partners, so the order doesn't matter whether you divide or multiply. First, it doesn't matter. So what do you guys suggest we do? If you were writing a test, where would you start here? If we were writing an assessment on this, where would we start? Thank you, Buhlale. In the denominator, would that not be easier? I think that would be much easier. Okay. So I'm going to leave my numerator as is, negative 8x to the power of 3, y to the power of 9. And I'm going to go to my denominator, okay? Besides the numbers, we still have similar bases, right? And we are multiplying. Let me use green. There we go. Right, so what is 4 times 2? At the bottom, we're in the denominator now. 4 times 2 is 8. And then we are multiplying in the denominator, so then it will be x to the power of what? If we are multiplying in the denominator, it will be x to the power of 4x, not y, be careful. I almost wrote 4 plus 5. I was confused for 1 second. Buhlalo almost caught me out. X is the blue ones. 1 plus 2, there we go. And y is indeed 4 plus 5. And if I simplify this, okay, I'm going to insert a line here and then start over at the top. Okay, someone asked me, where does the 8 come from? We multiplied the numbers, okay? So look here, we have a 4 and a 2. So I multiplied them. 4 times 2. Okay, now we're over here. This is now going to be our new expression, x cubed, y to the power of 9, all over 8x to the power of what? 8x to the power of 3 and y to the power of 9. Nice. Now we just left with division, right? There is no addition or subtraction. We need to divide. Let's start with our symbols. A negative divided by a positive. So my answer is going to be a negative. Thank you. 8 divided by 8 is 1 times x to the power of 3 minus 3 times y to the power of 9 minus 9. And this is going to give us negative 1, x to the power of 0, y to the power of 0. Both of those powers to 0 will be what? Will be equal to what? 1. So it'll be negative 1 times 1 times 1. So my final answer is just negative 1. Can you imagine, guys? All of that complication, all of it, if you simplify it, just goes down to negative 1. That is incredible. Okay, screenshotters, do your thing quickly. Hopefully there are no more questions. I hope I've answered everyone's questions so far that they've given me. Okay. I want to do another one. Let us do, okay, let our brains cool off a bit. But they can cool off at the end, ne? Isn't this what we just did? I'm pretty sure it is. Yes, it is. So this guy can go. Let's do this guy. We've been doing a lot of division. Let's multiply a little bit. Okay, a bunch of multiplication over here. Then we'll cool off and then we'll go off. Okay. There's something very important that we're going to learn in this question, but we'll get there when we get there. Where do we start with this one? Do we have brackets that can be simplified inside the brackets? Nope. Do we have exponents that can be simplified? Yes, we do. So I'm going to write equals -2. And inside my bracket, I have -3 squared as well as x to the power of 1 times 2, which is just squared actually, times xy squared times, okay, what's happening here? What's -3 squared? So we have two different types of -3 squareds here. We have this one and we have this one. They're two different questions, right? The first one has a square inside the brackets. It's this, -3 squared. And this means -3 times -3. The second one is -3 squared like that. This means negative times 3 times 3. Do we see the difference? I need to make sure we know the difference between these two. That negative that is outside the bracket is not squared, okay? The only time you square negative is if it's inside my brackets. Hopefully we all understand that. So the answer for the first one will be a what? What's -3 times -3? -3 times -3 is a +9. And the second one, my answer will be what? If the negative is outside and it's 3 times 3, -9. Do we see the difference between these two? I hope we do. Wonderful. Okay, don't get trapped by that one. So then it'll be -2, open brackets. We said -3 squared is +9 x squared times the whole shebang times, and this one we said is -9. Okay, now we are multiplying. Let's start with symbol. Okay, I'm going to tick off where I pass. Negative times a positive is going to give us, we are on negative times positive, negative times another positive, another negative, still negative, times negative, positive. So my final answer is going to be positive. Beautiful. Now let's go to numbers. What is 2 times 9? Times another 9. 162, I think. There you go. 162. Then we deal with my variables. I have an x squared over there times an x. So then my final answer is x to the power of 3. And y is on its own, so it's just y squared. That was beautiful. Thumbs up, thumbs down for that one. I need a thumbs up, thumbs down for that one. Okay, I have a few thumbs up, so that's good. Progress. Okay, and then to let our brains rather cool off, cool down. Oh, I had another. Okay, it's fine. We're cooling off. We're cooling off. Is there anything inside the bracket that I can simplify? No, there isn't. So let's just distribute. In this case, we have both multiplication and division there. So then it'll be 3 to the power of 3. X to the power of what? 2 times 3, which is 6. Y cubed all over Z to the power of 9. Now, as we know, we always simplify the numbers. What is 3 cubed? 27. X to the power of 6. Y cubed all over Z to the power of 9. Whew, how was the lesson, guys? That is where I'm going to end off today. Screenshotters, do your thing. Final thumbs up, thumbs down.